Okay, we're going to divide radicals. With a radical, there is a proper way to write a radical, and you cannot leave the radical in the denominator. Now, what I'm going to do is I'm going to multiply by the square root of 5 over the square root of 5. This is going to eliminate the radical down here. That's going to give me 7 times the square root of 5 over the square root of 25. And the square root of 25 is 5. So that gives me 7 onto the square root of 5 over 5. And my radical is gone. Okay. Now, sometimes we don't have to do that. This should have a square root symbol here. Sometimes we don't have to do that. Sometimes what we can do when we see something like this and we know that this number divides into this number, we can just divide. So 5 goes into 245 49 times, and we know the square root of 49. The square root of 49 is 7, and we're done. That one is simple. All right, sometimes we have what we call a conjugate. A conjugate, a math conjugate, is formed by changing the sign between the two terms in a binomial. For instance, a plus the square root of b and a minus the square root of b. Okay, so what I want to do in order to get this out of the denominator is I want to multiply by c plus the square root of d. Because if you'll remember, back over here, these are conjugates of one another. So a plus and a minus. So if I have a minus, I want to do plus. And when I do c plus the square root of d over c plus the square root of d, that's like, this is 1. It's the same thing as 1. So it's not changing my radical. It's changing the appearance of my radical, but not the equivalence. So when I do 1 times c plus the square root of d, that is just c plus the square root of d. Now, to multiply these two, it's like seeing them like this, like multiplying two binomials. I'm going to multiply c times c and c times the square root of d. That's going to give me c squared plus c onto the square root of d. Then I'm going to multiply these two, and this one's negative, so minus c onto the square root of d. And then this is plus the square root of d squared. And the square root of d squared is d. So what's happening when I multiply the same thing here, and they're both under the radicals, I just get the d. Whatever's under the radical goes away. So, and these two, the whole idea of the conjugate is that the middle terms and the radical goes away here. So positive c squared root of d and negative c squared root of d, my radical is gone. When you multiply by your conjugate, if you still have a radical in your denominator, you have done it incorrectly. There should be no radical in the denominator. So this gives me c squared, this goes to 0 plus d, and that's my answer. That's the answer in the denominator. The total answer is up here. This is in simplified form with no radical in the denominator. Okay. Let's try it with numbers. So I have 10 plus the square root of d. The radical is, the conjugate is 10 minus the square root of 2. Right? So that's going to give me 6 times 10, which is 60, minus 6 onto the square root of 2 in my numerator. Now I'm going to take my denominator and multiply those. 10 times 10 is 100. Now we know that because of this, I'm going to take you through a shortcut now. We know that these, and these right here are going to cancel out. Okay? So I'm not going to bother writing those down. I'm just going to do this part and this part. So I'm going to do 10 times 10. And the square root of 2 times the square root of 2 is the square root of 4, which is 2. And it's negative. So that is 98. Now, because I can simplify this, I must simplify this. So 60, I'm going to rewrite it down here so you can see it a little better. All three of these numbers are divisible by 2. So since they are, I must simplify. 60 divided by 2 is 30. 6 divided by 2 is 3. And 98 divided by 2 is 49. Now I am finished. And that is my answer. Let's do one more. The conjugate of the square root of 3 minus 1 is the square root of 3 plus 1. Okay? The square root of 3 times the square root of 3 is 3. And then the square root of 3 times 1 is 1 on 2 the square root of 3. And now I'm going to do my denominator. And remember our shortcut. The square root of 3 times the square root of 3 is 3. That's the square root of 9, which is 3. And then 1 times, negative 1 times 1 is negative 1, which is 2. So 2 is in my denominator. If I needed to simplify this, I would simplify it. I do not need to, so therefore, I'm done.